All right, everybody, we are going to go into Lab 0, click Gobo. This is going to be our first computer science lab. It's going to be an introduction to how Scratch works. And just so you know, when you're watching these videos, the most important thing is that you are getting the most out of it that you can. That means that if there's a part that you know really well, that you are already past me on the slides, feel free to fast forward through that part. If there's a part that you're really confused on, you're really stuck on, pause the video, watch it again, watch it again, watch it again. This is a resource that is here for you, and you need to use it as best you can to best serve you. Um, so let's get right into it. Lab 0, click Gobo. Getting started, the first thing you need is a Scratch account. You need to be using a school Scratch account, a Scratch account that your teacher has provided for you by giving you a link to join the Scratch classroom that you're in. If you are not using that account, your teacher will probably not accept your work. That's all that's going to be said for now. Please figure out how to make an account with your teacher if you have not done so already. The first thing we're going to learn about in this lab is how Scratch works. It's very self-intuitive. It's very intuitive, I should say. There is a palette. This is a collection of all the code blocks that you're going to use in Scratch. There is a scripting area. This is where you bring all of your code blocks to write your code. This is your stage. This is where all of your characters and animations and pictures go. This is where everything that happens in your code is viewed, is seen. If you design a game, your game is here. If you design an animation, your animation is here. This is the stuff that actually happens. This is the sprite control. This is where all the pictures, all the characters, all the costumes, everything in your game, all of your assets. I keep referring to it as a game. It's not necessarily a game. I've made a lot of games before, so that's going to be a common thing that I might accidentally slip out and say. But all of your assets, all of your sprites are going to be in the sprite control section. And finally, there's the toolbar. This is where you're going to go to save your files, and that's about it in the toolbar. So the first thing you're going to want to do is you're going to want to go to Scratch. You're going to want to make sure you are logged into your Scratch account, and you're going to want to click this Create button, and that's going to take you to the page we just saw. All of your code is over here on the left side. You bring your code into this middle section and bring them together to write code. You click your play button and your code will run. And this section down here will hold all of the characters that are in your stage. All of your characters, all of your little pictures, they're in here. You have different code for different characters. So if I click on Dot and I tell Dot that when the green flag is clicked, that Dot should say hello. The scarf is not going to say hello. Only Dot says hello. The sprites run the code inside of the sprites. This code does not run in all the other sprites. It just runs in the sprite that it's coded inside of. To start with for this lab, we're going to delete this cat. We don't need him. And we're going to see what it says from here. So this is just an introduction to how Scratch works. The Scratch stage is actually a coordinate plane. It's a Cartesian plane. If you've seen coordinate points in math, that's the same way your Scratch screen is laid out. That's actually the same way every computer screen in the world, every TV screen is laid out, is kind of on its Cartesian plane. That's how a lot of our information on our computer is kind of how the computer knows where to put things on the screen. So if I look up coordinate plane, this is something really useful for early Scratch lessons. XY grid. This is really useful for early Scratch lessons for keeping in mind where things are. It's a coordinate plane just like in math class. We're not going to review that right now. There might be some time in class, but hopefully you guys are a little bit familiar. Maybe you've seen it before. Maybe you've seen this concept from math class. We're going to start our lab. Our lab is going to start by bringing in a sprite. This is on slide 13. This is the first step. We're going to bring in a Gobo sprite. The place we bring in sprites is this choose a sprite button. We're going to click the magnifying glass to search a sprite, and we're going to type in Gobo. You guys are free to use other sprites if you want, but I'm using Gobo for this example, so if you're using Gobo too, you'll be able to follow along much easier, but feel free to customize this and make it your own. This is Gobo. He's the little yellow guy. Let's see what step 2 wants us to do. Step 2 wants us to click the Costumes tab. The Costumes tab is in the palette. It's this tab right here. It's next to code, and it shows us all the different pictures that make up Gobo. Now, it looks like we're not going to need costume 3. It's telling us to delete that costume. So every one of Gobo's costumes has a little trash can. We'll click on costume 3, and we'll click on the trash can to delete it. The next thing it wants us to select costume 2. So I'll click on this second costume, costume 2. And it wants us to click the flip horizontal button. So now it wants us to click this flip horizontal button. Now Gobo is facing the other way. So we have one costume facing to the right and one costume facing to the left. Okay, it looks like I'm doing the right thing so far. I have 2 costumes, one faces right, one faces left. Now, program the sprite to change costumes when Gobo is clicked. We're going to go back to the code tab. We were in the costumes tab. Let's go back to code. And let's find these 2 code blocks. When this sprite is clicked and next costume. When this sprite is clicked is an event. An event tells the sprite when it should run its code. In this case, our code is going to run when the sprite is clicked. So when the sprite is clicked, we're going to take next costume. So now when I click the sprite, he goes to his next costume. And very conveniently, it looks like costume 1, the next costume is obviously costume 2. But costume 2, the next costume loops back around to costume 1, which gives us little looking back and forth kind of thing, which is useful. That's really cool. So now we have a Gobo that looks back and forth. Click on Gobo. If your script works, he'll face the other way. That works perfectly. Now we're going to introduce operators. The random block generates a random number, perhaps a random variable, a number, from 1 to 10. We can change this number to anything we want, so maybe negative 10 to 10. And whenever I run this code, whenever I click on it, it's going to generate a random number between these 2 values. That sounds like it could be a really useful code block for a lot of things. Let's see how we use it here. We're going to add a line of code so that every time Gobo is clicked, he's not just going to turn back and forth. He's also going to go to a random position. The way we're going to do that is with this go to block. That's a motion block. Any block that tells Gobo where to go, any block that tells your sprite where to move is going to be in these blue go to blocks. In these blue motion blocks. We're going to grab go to, and we're going to tell him to go to 2 random positions. I'm going to use negative 100, positive 100, negative 100, positive 100. And now when I click on him, he goes to random positions. Out of curiosity, I'm actually just going to try that for just the X. Let's see what happens if I just do random X. It looks like he's moving back and forth when I have just random X. Let's try random Y. It looks like he moves to different positions up and down when I do a random Y. So it looks like Y is going to mean how far up or down he is. And it looks like X is going to mean how far to the left or right he is. Now, if you want, you can fill in these 240 and 180 numbers into these blocks to make it more accurate. That would make your code, that would give Gobo a much wider range of where he can go. My Gobo is never going to go over here. You guys should definitely do that. Now, my Gobo bounces all around the screen. I'm pretty happy with that. I'm pretty proud of that. I want my teacher to see that. I'm going to make sure to click this orange share button. Nothing I do, none of my work can be seen by my teacher until I click that orange share button and it says my project is now shared. I'm going to click see inside to go back inside. And actually, I forgot a really important step. You should make sure to name all your work. Let's name this Lab0. Let's name this Lab0. Click Gobo. Smiley face. Lab0 click Gobo. We have a few more steps before we're done with this lab. Right now, when we click Gobo, he goes all over the place, and that's really cool. But I want to try to see some more variables. I want to try to see some more interesting variables. So we have this X position and Y position variable. Our X position and Y position are going to be numbers. Variables are numbers that can vary. that can be different things. So this X position variable stores the value, the number that represents where Gobo is on this Cartesian plane. So at negative 44, he's over here. At 0, he's here. At 240, he's over here. That variable, that number, is stored right here in this X position. Whenever I click on him, he goes to a different position, and we can see these variables updating based on where he is, based on where Gobo is located. Bit of a side note, these variables are called integers because they can be positive or negative, but without decimals. These are integer variables. That's not super useful. That's actually incredibly useful to know. I'm so sorry. That's incredibly important and incredibly useful to know. Once we start working in Python and some other programming languages, it's really, really good to know what kind of variables you're working with. So the way I got these to show up, by the way, I clicked these checkboxes next to X and Y. Now I can see my X and Y position, my current X and Y position show up all the time for me. That's really useful. The last thing we're going to do is we're going to make it so that he has an initialization. Initialization means some starting position, some starting state. So we're going to take a green flag. That means when the game starts, when I click the green flag to start, he's going to go to the starting state. He's going to go to the middle of the screen. I'm going to use 0, 0. I think it's a little bit cleaner. I'm going to tell him to go to 0, 0. So now when I click the green flag, he goes to 0, 0. And I'm going to tell him to say, let's see what it wants us to say. Welcome to Click Gobo. Click me if you can. So he's going to give us a little taunt. Welcome to Click Gobo. Click me if you can. So now when I press the green flag to start, he'll say, welcome to Click Gobo. Click me if you can. And now my code works, and I can click on him. And that's very awesome. We're going to introduce one more new topic before we move on from this lab. We're going to introduce loops. A loop is something that makes some code happen over and over and over again. A loop allows us to keep doing new things. On this next slide, it's going to tell us to add a forever loop at the end of the when I am clicked. So when I am clicked, we're going to end that with a forever. And it's going to say to add a wait block in there. It's going to say to add wait 2 seconds in there. That's what this slide says to do. But we're going to be forever waiting, but not doing anything. We're just going to be waiting forever. We need to tell Gobo what to do every 2 seconds. This code here is just going to run once each time he's clicked. It's going to run once each time he's clicked. This code is going to run forever once he's clicked. He's going to forever start waiting 2 seconds. And then we'll tell him to go to a random position after 2 seconds. So now when I click him, he's not just going to do it once. Every 2 seconds, he's going to go to a random position. He'll go to this random position every 2 seconds now. If I didn't have the forever there, he'd just do that one time. When I click on him, he'd just do that one time. He's going to go once, and now he's done. He's not doing it forever. But we want him to run away forever. Loops are extremely important concepts. We're going to use a lot of loops in this class. It's something you should definitely try to become familiar with. You guys can try this slide number 25, all on your own. The last really important topic I want to go over is adding comments. It's really important for your teachers and for yourself. And if you're ever working in pair programming, if you're working with a friend, it's a lot harder to read code than it is to read words. So what I could do is I could just click my code and add a comment by right-clicking my code with the right mouse button. And I can add a comment, and I can say what this code does. This code initializes the game. Initializes means sets everything to the starting state, the starting positions. That's an important vocab word. This code, when the sprite is clicked, it's going to go to a random position, and then it's going to keep going to random positions. And I can keep clicking him. Click, 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 click. This code makes Gobo go to random positions. So just notes that just let the teachers know, let yourself know, let your friends know, let people who view your work know what your code is doing. Maybe when you write 1,000 lines of code, you'll lose track of what things are doing. Having notes is extremely important. Annotating your code with notes is extremely important in programming. That's the final little bit for this project. You can make sure it's shared. It should save automatically, but you can click save now to make sure that your work is updated. And then you could submit this to Google Classroom. You could submit this in 2 ways. You should do both. I want you to screenshot your code. I want you to screenshot your code. I want you to save that screenshot and send that screenshot to Google Classroom. We've already sent lots of screenshots to Google Classroom. Hopefully that's not difficult. I need this screenshot in Google Classroom. This is what you're getting graded on. In addition, you should go to the projects page. You should click copy link. You should click copy embed, and you should add this game to your Google site. If I go on Google Sites, I should have my website that I've been working on. This might be a student's website, but that's okay. And I can add pages. Maybe I'll make a new website because this one, I shouldn't be working on there. And I can add a page for my Scratch Labs. And I can add a sub page to Scratch Labs by clicking these 3 dots and clicking add sub page. And now this is going to be a really cool part. We're going to make a page for Lab0. Click Gobo. And on this sub page, I'm going to insert the embed code for my game. And now I could play my game on my portfolio website. That's really cool. If you finish early, you should continue on and do some bells and whistles. There's lots of really cool things you could do, like updating your Google Classroom website and making it more beautiful. Maybe changing some themes around and making it more pretty. You can also add to your game. I've had students build aim trainers in the past. Maybe you make some systems. Maybe you change Gobo's costume to a target. So you're trying to like target him and click on a target. Maybe you make multiple targets, and maybe you make some timers or things that keep score using this variable code. You would use this variable code to make timers or to make things that keep score. That might be complicated, but if you finish early, you might have time to figure it out. If you don't want to do bells and whistles, if you're very happy with your project and you don't want to add to it, I highly encourage you to spend your extra time on code.org. That's about it for this first lab. If you guys have any questions, please, please, please reach out to me, assuming I'm your teacher. Reach out to your teacher, ask for help. Everyone is more than willing to help you. This is a difficult topic, but you are fantastic, wonderful, amazing students for even being in this class. And I'm sure you will do this fantastically. This first lab, there's not a lot that you guys are doing on your own besides slide, I think 13 or something. There's one slide 25, that I left for you to do on your own. This is an early lab. It's an introduction. Hopefully you guys are picking this up and doing very well. I look forward to seeing you guys in the future. I look forward to seeing these submissions. I'm excited to see what you add to this, what crazy costumes you could Gobo. Maybe you make him say funny taunts. I'm really looking forward to it. Please, please, please let someone know if you need help. Thank you and have a great